Today we are going to start a lesson on complex numbers. Okay, I would not give you a summary, but basically what I'll do is I will just recap some of the main ideas when it comes to the main points. Okay, so just look at question 1 first. We'll just cover the first session, cover the first part on algebra of complex numbers. So for the first question, if you look at it, basically you're just talking about solving of equations involving complex numbers. For this part here, if you look at it again very carefully, what you need to take note is asking you to find the unknown P and Q given a root. And if you try to recall what you have learned in secondary school, it's something similar to binomial, it's something similar to the factor and remainder theorem. In other words, if you look at it, basically, if we are given a root, to find the unknown in the equation, you just need to substitute the values of the root into the equation, and from there, you form an equation to solve for the unknown. And the basic ideas behind here is actually the same. So what you need to do here is, now, given a root, but the root is a complex root, and given a cubic equation, how are you going to find the P and Q? Well, applying the same ideas, what we could do is, we could just substitute the values of Z into the equation, and it must satisfy the equation since it is the root of the equation. And in this case here, the root of the equation is 3 plus 2i, which means what you need to do is whenever you see Z, you just simply replace your Z by 3 plus 2i. Okay, and you end up with getting an equation which is like this, where when Z is replaced by 3 plus 2i, and this equation will consist of two unknown P and Q. How are you going to proceed with one equation but two unknown and solve for P and Q? Well, before we look at it, we may actually try to ask yourself, how are you going to simplify the equation further first before you solve for P and Q? In these questions here, the first part of the question is they didn't say without the use of graphing calculator. If they didn't state without the use of graphing calculator, for the first part basically, you can try to use graphing calculator to simplify expressions like 3 plus 2i cubed, 3 plus 2i squared, and 3 plus 2i basically simplified form. Okay. So what you could do is you just need to use GC and you would be able to work out the expressions from 3 plus 2i cubed, 3 plus 2i squared. Okay, and this is 3 plus 2i, and from there you will be able to simplify the equation further before you find your P and Q. But it comes to the questions where, how do you solve for two unknown when you have one equation? Now, just remember complex number here, there is one special property that for complex numbers, it consists of two parts, real and imaginary. So as a result, actually, it's just similar to vectors when you talk about vectors equation. When you try to have a vectors equation, you can further break down into three equations with three component x, y, z. So similarly for a complex numbers equation, what you could do is you actually can further down breaking down into two equations because you can look at the real part and imaginary part. So as a result, what you could do now is you try to simplify this. So you can actually rewrite it into real part and imaginary part. So it has minus 18 plus 5p plus 3q minus 65, that's the real part, plus the imaginary part, which is 92i plus 12pi plus 2qi, and that equals to 0. Okay, so once you look at it, now you can actually safely see that this will be your real part and this will be your imaginary part. Okay, and since this equation here, the other side is actually equal to 0, which is actually the same as saying that is 0 plus 0i. You can simply equate and form two equations where you end up with real part is equal to 0 and further simplify it into equation 1. And imaginary part equal to 0 and further simplify it into equation 2. Okay, so with these two equations involving P and Q, you can just use your GC and solve for 1 and 2 to solve for your P and Q. So that actually answers the first part of the questions where you need to find your P and Q. But that's not the end of the story. Okay, that goes your P, value of P and value of Q. But that's not the end of the story because you are supposed to actually carry on for part 2. Where part 2 now, you are not supposed to use GC. Okay, not supposed to use GC to solve for all the other roots of the equation. So what should you do? Well, if you look at the equations again very carefully, there is one very important theorem that you have learned under complex numbers, that if you are given a polynomial equation and if all the coefficients of the polynomials are real, then the roots will occur in conjugate pair. In other words, it simply means that in this case here, since all the coefficients are real, given P and Q are real, and 3 plus 2i is a root, therefore, the complex conjugate of 3 plus 2i, which is 3 minus 2i, is also a root. And as a result, you would be able to write down the factor of the equation given the root. And please don't be confused between the root and the equation. Okay? For example, if in this case here, you notice that the roots for this equation, you started with 3 plus 2i. And since all the coefficients are real for the polynomial, you know that actually the 3 minus 2i is also a root. Okay? You will be able to write down the factors. They are not the same, but you can actually use one to find the other one. The factors will actually be equal to z minus the root. So the first factor will be 3z minus 3 plus 2i, and the other factors will be z minus bracket 3 minus 2i. Okay, so once you have the roots, you can form the factors and vice versa. Now, you can write down the factors, and with the factors, you will be able to try to first factorize the equation or the polynomial expressions completely before you can find the roots of the, for corresponding to other factors. Okay, so let's write down what the two roots. First root, okay, is 3 minus 3 plus 2i. So the factors will be z minus bracket 3 plus 2i. And similarly, for the second factors, the root is 3 minus 2i, and then you can write down the corresponding factors. Now, with these two factors, how are you going to get the third factors? Knowing that this is a cubic equation where actually the degree is 3. When you try to combine the two linear factors here, you notice that you will get a quadratic expression. So as a result, the left behind or the remaining factors should be linear. Okay, so now the thing is, how are you going to simplify the quadratic factors and all? Or in other words, how are you going to get the quadratic factors by expanding out the two linear factors? Now, maybe I just try to illustrate. There are some important ideas based on that. Okay, if you actually factors which consist of roots that are conjugate of each other. For example, one of the factors is z minus a plus bi, right? And the other factors is z minus a minus bi, when the roots are complex conjugate. Then when you try to expand out these two linear factors, what would you get? Well, using the ordinary kind of expansion, z multiplied by z, just expand it out ordinarily, then you would get z multiplied by this. Okay, you get minus a minus b I z, right? And then after that, you just expand this out. Then you get minus a plus b I z. Okay, and then finally, these two you multiply together, you get minus minus is plus. A plus bi multiplied by a minus bi. And if you try to simplify, and if you don't make any colors missing in between, you should be able to end out after you simplify everything. You notice that the minus bi and plus bi will cancel out. You will end up with minus 2a z squared minus 2az. Now, how about this? Now, what is a complex number multiplied by the conjugate? This is some important properties that I think you should take note. When you have a complex numbers multiplied by the conjugate, okay, if you can still remember what you have learned, let's say W is equal to X plus IY, and your W conjugate will be X minus IY. When you try to multiply your W and W conjugate together, actually this is, know that it gives you mod of W squared. And how do you find the modulus of a complex number? Basically, it's just square root of x squared plus y squared. That is a modulus, but it's mod of square of it. So that means your W conjugate basically will give you x squared plus y squared. So as you just make a direct comparison, what you could see is your A is your x and now your B is your y. So when you try to simplify this expression, okay, you will notice that you will be able to get A squared plus B squared, right? So this is something that you need to take note, right? So okay, we just need to try to proceed to again from where we stopped previously. That is this part here. Okay, so this is the expression that is very important, this part, which I've actually just explained. And this is your A plus BI multiplied by A minus BI will give you A squared plus B squared. So as a result, when you try to do the expansion for these two linear factors, what you end up with is, these two are the linear factors I'm referring to, these two linear factors when you try to expand it out, okay, you will end up with z squared minus 2, your A is 3, so it's just minus 2 times 3z, okay, plus A squared plus B squared. Okay, this is your A and this is your B. So your A is equal to 3 and your B is equal to 2. Right, so it's A squared plus B squared, which turn out to be 13. Now, these are the two, this is the quadratic factors you obtain. But you know you need one more linear factors in order to make up, okay, to expand and get a polynomial of degree 3. So what you need now is you need a 2x cubed, z cubed. But you already have the 2z squared. So what is lacking now is what should you multiply to your z squared in order to get 2z cubed? Well, it would be linear, so it will be in the form of az plus b. So in this particular case, if you look at it, it should be by right, it should be 2. Okay, so that you will be able to get z squared multiplied by 2z, which gives you a 2z cubed. Right? Now, what else do you need? Followed by that term, it should be a constant. You don't really know what the constant is, but you can do by inspection. The constant, you can let it be plus k, you can let it be minus k, ultimately it doesn't really matter. Okay, so in this case here, I just let it, the factors to be 2z minus k, so now my job is to find k. Because if I can get all the factors now, I will be able to work out the roots. Okay? So for this part here, in order to find the value of k, the simplest way to do is actually try to compare the real parts. If you look at the real parts very carefully, in fact, the real parts here on the left-hand side is minus 65. Now, in order to get the real parts on the right-hand side, what you need to do is basically you just multiply constant, not real parts, sorry, the constant, okay? Constant term. Okay, so in order to get the constant term, basically you just need to multiply the constant to the constant, which means you just need to multiply minus 13 to minus, positive 13 to minus k, which means that you will end up with left hand side is minus 65, that's constant term, and the right hand side, when you try to multiply the constant to constant, which will give you 13 multiplied by minus k, you end up with one equation, and from there you can solve for your k, the value of k. Now, once you have worked out all the three factors, you will be able to work out the roots by equating all the factors to 0. So ultimately, what are the roots? One of the roots will be 3 plus 2i, the other roots will be 3 minus 2i, and the final roots will be corresponds to the factor where you let 2z minus k equals to 0, where your k is equal to 5. You will end up with So your k is 5. So let me replace it by 5. You end up with z is equal to 5 over 2, which is 2.5. So the final, the last roots will be 2.5. Okay? So these are the two remaining roots on top of the original given roots, which is 3 plus 2i. Okay? So this is one way of solving the equations when first you have to find the unknown given a root, and finally you have to factorize the expressions completely to find the other factors of the equation. Now if you just make an observation, you notice that actually there is another way to solve the equation. And if you look at it again very carefully, you notice that when we try to actually find all the factors of the polynomial expressions, we didn't need to make use of the value of p and q. In other words, that means that actually you do not need the value of p, which is this is the value of p minus 17, and this is the value of q. You don't really need the value of p and q when you are trying to find the factors. Okay, find out all the factors. So that suggests that actually there is another way of solving this question by just doing part 1 and part 2 concurrently, in the sense that you can try to find out all the factors first before you find the p and q. So this is something I think is an interesting observation you could observe and take note of. That is, p and q can be found after you obtain all the factors. So if you just look at the alternative solutions, this is what we're going to do for the alternative solution, which means we are trying to find all the factors before we find p and q, which means that we don't follow the order according to part 1 first, followed by part 2. Okay. So basically, if you look at this, imagine we don't really know, we have not found our p and q, right? So what could we do first? Well, basically from the previous solutions, you notice that you can just try to find all the factors first. Okay, so in this case here, p and q is not known, right? Okay, so I just talked it out, right? P is not known, q is not known. Okay, now without finding p and q, actually this is what we have worked out. We actually try to find out all the factors first by using one of the factors that's given. Then we can deduce the other factors by using the theorem that all coefficients are real. The roots will occur in conjugate pair. That will end up with another factor. Okay, which is this one. Right, this is the root, and then you get the factors. And then at the end, by inspections, you get the third factors, which is actually this. Okay. All right. So if you notice that when we are trying to do all these things, actually this part here, the alternative solutions, basically the first part is actually the same as the previous method, right? Until we reach this stage where we get all the factors. Now, after we get all the factors, that's not the end of the story yet. Okay, we get all the factors, even without knowing the value of p and q, we can actually work out all the roots. But basically by just equating all factors to 0. So by equating this to 0, you get one of the roots. Equating this to 0, you get the other root. So you get the two remaining roots. Okay, which is p minus 2i and 2.5. Now, but that's not the end of the story. Don't forget, your job is also to find your value for p and q. So ultimately, after you reach this stage, you are not going to end here. You have to work out what is the value for p and q now. In other words, that means that now you have to ask yourself, what is this value for p and what is this value of q? But this is an expression. You don't know your left hand side because p and q is not known, but you have worked out the factors. All the factors is represented by it's all indicated on the right hand side. So what you need to do is, if you want to find p and q, you can just compare coefficients on both sides, which means that you just need to do the expansion, ordinary expansion, but you can just multiply out, okay, your z square, ordinary expansion, and expand it out. So you should have altogether 6 terms if you go on. And after you simplify, you will be able to get a cubic expression in this form. And therefore, after you get to this part, you just need to compare coefficients again, where you can see that, yeah, well, what is your p? Your p is minus 17. And what is your q? Your q will be positive 56 by comparing coefficient of x, z squared and z respectively. Okay, so basically you notice that in order to solve equations like that or questions like that, you actually can do both parts concurrently. Okay, so this is another alternative method. If you ask me which method is better, basically there is no right or wrong answer. It's whichever style suits you, okay, you just apply them as long as you do it correctly. Okay. Now, if you look at this part of the questions, you notice there's a possible further extension for this, where you actually can just look at, okay, same year, RI papers, okay, a short question. It's a similar question. The only thing about this that you have to be very careful when you look at this question is to take note. When they actually talk about K, where K is unknown here, okay, but they didn't mention what is the value of K. In other words, that means that your K may not be real. Now, if this is the case, then what you have to do is you have to do something that is a bit different because you know the one of the roots is I, okay, but the problem is you don't know the rest of the roots because your K may not be real. That means that the complex root may not occur in conjugate pair. So as a result, when you try to solve this equation, then you have to be very careful in the sense that, okay, so for this one, how are you going to proceed? Well, you just continue with this, but now you cannot assume you have only one root, therefore you can only form one factor. The root is I, so the factors will be z minus I. Okay, so this is the factor. Now, in order to get the other factors, and you know that this is a cubic equation, that means that obviously the other factors must be quadratic because you don't have other factors at the moment that you know. So you know it must be quadratic. So what is this? How are you going to get z cubed? In order to get z cubed, you need to multiply your z to z squared. Now, if this is quadratic, that means this is not the only term. You should have two more terms followed by az plus b. Okay. So now the thing is, how are you going to find a and b? Well, basically you can use the alternative approach. In other words, that means that actually you can just find your a and b before you find your k by comparing the coefficients of z. So for example, in this particular case, if you just continue from here, you try to compare coefficient of z squared, right? You notice that the left hand side there's no z squared, so the coefficient is 0. The right hand side, in order to get the coefficient of z squared, you actually need to multiply these two terms together, okay? Which is minus I multiplied by z squared and z multiplied by az. Which is minus I z squared plus az squared. So from there, you can solve for your a. Alright, and then if you try to compare coefficient of z, you cannot compare coefficient of the constant, compare the constant term. The reason is because constant is k, which is not known. So that's why you try to compare coefficient of z instead. Okay. What would you get this time round? Okay, the right hand side coefficient of z is 2. Left hand side, the right hand side, when you try to do the expansion, coefficient, how are you going to get it? Basically, it will be just multiply the z term, right? So you want to get a z, you would have multiply minus I z, or you would multiply your z to b, which is plus bz and minus iaz. So it's minus ai. And then from there, hopefully you will be able to find your b. And once you know your b, you can actually just put your a and b into the equation. Put your a and b into the equation, and you will be able to solve for. Okay, by expanding and comparing the constant term. Okay, so what is other possible extension for this type of questions? Well, other possible extension for this type of questions would be if you are given the original equations, you are supposed to find the roots of the original equation. And now they say deduce the roots of a new equation. Then usually for this sort of questions, you try to establish the relation between the old equation, original equation, and the new equation. How are you going to do that? Try to create some terms that is similar. For example, in this particular case here, if you look at it again, this new equation here, now you notice that this is plus 65, but this is minus 65, this kind of a sign. So what I could do is I just multiply negative 1 to the new equation. That means I'll just convert, okay, just multiply negative 1 to both sides. So that I can do the conversion, and after I done the conversion, then you notice that actually this minus 65 and this minus 65 is the same. So at least you created a term that is similar. Then you can make comparison for the rest of the terms. Okay, what is the easiest way to compare? You compare your Z and your W. Okay, looking at your Q. Now, if your Q here, this is Q and this is also Q. So if you look at it, these two are the same. So what does it say about Z and IW? Basically, it suggests that probably your replacement will be Z equals to IW. But that's not good enough because you actually have to check that this replacement works for other terms as well. So if you are going to replace your Z by IW, then you must make sure that when you try to do the replacement here, this term will actually give you minus IW, right? And this term here will actually give you minus IW cubed, right? So we have to do the checking. So if it is Z squared, okay, if it is Z squared, then it becomes IW the whole thing squared. So when you try to expand it out, it's I squared, W squared, but I squared is minus 1, so it's minus W squared. So if you look at it, yes, when you try to replace your Z by IW, your Z squared is minus W squared. And it works. Okay, minus W squared, right? Minus W squared. And you actually have to do the same when you try to check for the Z cube, which is Z cube here, it will be IW cube, which is actually I cube W cube, but your I cube is minus I, right? So it's minus IW cube. And if you look at it again, yeah, you notice that your Z cube corresponds to minus IW cube. Okay, where your two is the same. So you notice that actually, yes, this replacement works very well because when you try to do the replacement throughout, replace your Z by IW, you notice that it will be able to convert or transform into the new equation. Okay, so if this is the case, then you will be able to work out the new root of the root of the new equation, which is you will be able to solve for your W, because if you notice that this your replacement is Z is replaced by IW, then you will be able to solve for W because your W is just Z over I. And with the values of Z you have found from the previous part, from the original equation, by substituting the values of Z inside here, you will be able to find out your W, right, after you simplify all your expressions. Okay, so this is the possible extension for questions like that. Now, if there is no problem here, we'll just proceed to question 1b, solving of equations. How do you solve equations like that? Okay, now it's something similar to the previous part. It's also solving equation, but this type of equation, there's a standard way of solving it. In general, if you have equations which is of the form Zn equals to a complex number, you actually rephrase it. For example, in this particular case here, you're talking about Z4 equals to minus 1 plus square root 3i. And if you try to rewrite it when you talk about finding your Z is just equals to minus 1 plus square root 3i, the whole thing to the power of 1/4. In other words, to put it in another way, it's just simply asking you to find the fourth root of minus 1 plus square root 3i. So how are you going to find the fourth root of minus 1 plus square root 3i, knowing that there should be 4 answers because this is actually a quadratic equation, right? Okay, so what should you do? Well, to solve for this kind of equation, there is a standard way of doing it. First of all, there are standard steps for you to follow. So first of all, if you look at it again very carefully, okay, if you try to recall what you have learned, 1. You try to express this complex numbers here, which in this case is minus 1 plus square root 3i, in the form of REI beta. And what is R? R is just modulus of minus 1 plus square root 3i. So in this case, if you work out correctly, it's just square root of minus 1 square plus 3 is square of square root 3. In this case, it's just positive 2. And what is theta? The theta will be the argument of, let me shift it back, get back to the screen there. Okay, your theta will be argument of the complex number minus 1 plus square root 3i, where in this case here, you have to be very careful when you want to find the argument, because you need to actually locate the position of minus 1 plus square root 3i. Where is this? Where is the point? Now, if you try to recall, okay, for a complex number, actually you can just try to associate it into an Argand diagram where there's a point on the Argand diagram. For this minus 1 plus root 3i, actually the point falls in which quadrant? The point falls in the second quadrant where x is negative and y is positive. Okay, let me just so let me just draw second quadrant here. X is negative, y is positive. So this point here, the coordinates is minus 1 and square root 3. Okay, this is the point. And what is the argument? The argument is just this angle here. Okay, measure from the positive real axis. How do you find the argument of complex numbers? My advice is try to find the basic angle, which is this angle here. Okay, to find this basic angles, what you need to do is you construct a right angle triangle, and you can see that your basic angles here is just tangent, inverse, opposite over adjacent. Opposite is actually the y, and adjacent is actually your x. Okay, absolute value because I'm talking about the basic angles. Huh? Let's get back to this. So in this case, it's actually opposite, which is square root of 3, adjacent, which is 1, the length. And this is my basic angle, but because the angle it falls in the second quadrant argument, the point falls in the second quadrant, so the argument in the second quadrant is simply just pi minus the basic angle. Okay, and tangent inverse root 3 is pi by 3, so you'll be pi minus pi by 3, which is actually 2 pi by 3. This is the argument, okay, for the complex numbers, but that's not the end. This is just the beginning. What's the next step? So we have found our R. We have found our theta. So this is 2ei theta. And then what's the next thing? The next thing is you have to try, because you know that there should be altogether 4 answers, right? So you have to try to generate other answers. So what you need to do is, in order to generate the other answers, is you add 2k pi to your theta. After you have found your theta. Okay? Now, so in this particular case, you add 2k pi, and then you have to tell them what is the value of k. The k is just all the integer values, right? Integer values. Now, so usually if the question say that you have to find, usually they will talk about principal argument, and the principal argument they will specify is from minus pi to pi. Now, for cases like that, you have to be very careful in the selection of values of k. If they didn't specify your theta, it's okay to just take the value of k 0, 1, 2, 3, and that gives you the answer, because you just need 4 values of k to generate 4 answers for that. But in the case where you have to find the value of theta from minus pi to pi, then you have to choose your k carefully, because if you just simply select 0, 1, 2, 3, it may not give you the answer that falls in the region. Okay, so what you could do is you start from 0, then after that you just extend 0 plus minus 1 plus minus 2, and you go on and you see how many values of k you need. Now in this particular case, you need altogether how many values of k? You need altogether 4 values of k. So you start 0 plus minus 1, that gives you 3 values. You need one more value, so it's either plus 2 or minus 2. So if you have no idea which one to choose, then you just need to substitute both values of k inside, -2 or 2, and then you check which is the value of k that will give you the region that falls in this principal range. Okay, from -pi to pi. Alright? Okay, but that's not the end yet. You have decided on the values of k. Your job is to solve for your z. Right? You have to get rid of the 4. So in order to get rid of the 4 here, you just need to take fourth root on both sides. Okay? So you just need to raise power 1/4 on both sides, and you will end up with this. One more thing you have to take note. Be very careful when you try to find the, when you take the fourth root, don't forget, don't leave out the 2. Okay? Don't leave out the 2. This is the part a lot of people always forget. Right? So it becomes your r becomes r to the power 1/4. Okay? Then of course subsequently this value here you must also divide by 4 because you have to multiply by 1/4, right? Everything. Okay? All the powers now becomes 1/4 of the original one. Okay, now usually it's good, it's sufficient to just stop here. Okay, but if you really, if they give you many marks for this part, then in that case you may want to list down all the roots. So in this case, you just need to substitute the values of k into here with -2, -1, 0, and 1. You will be able to list down all the 4 roots. Okay, as shown. So that will complete all the 3 steps. Okay, the last step is take fourth root. Now, it need not to always be the fourth root. It depends on what is the equation you're solving. If you're solving for z4, of course, you'll be finding the fourth root. But if you're solving for z5 equals to a complex number, then you'll be finding the fifth root and so forth. Okay? All right, now, let's come to the last part of this question. If you look at it, the last part is deducing. This questions on deducing part. So if you talk about deducing part, then you have to make use of the previous part to get the answer. Okay, now how are you going to do it? Now, if you try to recall, just now we actually have mentioned something about the extension, right? The extension of it from finding an equation of the whole original equation, the root of an original equation. Then you try to get a new equation, and you have what is the replacement to convert into new equation. And then after that, you will be able to find the root for the new equation by looking at the correct replacement. So for this particular case, what you need to do is, if you look at it again very carefully, if you want to establish and you want to look for correct replacement, you really need to look for the equation and look for the similarities between the equations. How are you going to do that? Okay. Now for this part here, let us make an observation. If you try to actually look at it, these two equations, when you try to actually make a comparison, they look very different. If you want to make you want to establish some relation, at sometimes you need to make some terms the same. If it is completely different, it's very difficult to make observation. So as a result, if you look at it, you notice that actually probably you should be able to try to write it as something to the power of z equals to -1 plus square root 3i. But if you look at this part here, it's minus I, and these two are not the same, right? Different. Okay, these two are different. So in other words, what could you do? Try to convert into the same thing, and don't forget, actually there is a root 3 plus I here. Okay, so what should we do? There are only two ways, right? Now, do you want it to be Z4? And this is already W4. You want the coefficient here, if possible, to be 1. Okay, if possible. So maybe you should try to do something like you either bring this term over to the right hand side, or you try to bring the minus I to the other side. Then you ask yourself, if I bring, okay, so you just try to do some checking. Naturally, if you look at it, if you are fast enough, you notice that actually it will be more effective if you try to bring minus I over to the other side. You will be able to see why I say that very soon. Okay? Yeah? Right. So when I bring the minus I over to this side here, you notice what happened is when you try to look at it and simplify it further, you end up with root 3 over minus I, And then plus I divided by minus I will give you minus 1. Okay, then the other side, the W, I bring it over. So I get 1 over W power 4, which I can take out the power 4 here. Okay, then it still looks quite different as compared to this. Still look quite different. Okay, so what should I do? Then you look at it. Should you try to simplify square root 3 over minus I? When you try to simplify it further, what do you notice? You notice that, how do you simplify this, by the way? Will multiply by the conjugate, right, of the complex numbers, which means you multiply by I, okay, both numerator and denominator, which will give you square root 3 multiplied by I, both numerator and denominator, and then minus 1 over W power 4. Okay, and comparing this with this, and now you will be able to see, yes, you have root 3I minus 1, and therefore now you just need to compare the other side, which means that a logical kind of replacement will be replace your Z by 1 over W. Okay, if you can actually establish and see a correct replacement, then you will have no problem to continue to find the values of W. The job to continue for solving of this equation when they find the roots, in other words, is to find W. What is your W? Correct? Okay, but then actually what you could do is, since you know your Z is 1 over W, that means your W is equal to 1 over Z. You make W the subject, okay, so that you can find W, and you just need to substitute the values of Z inside, because you have found your Z. This is the value of Z, which you have found, right? Okay, this is the value of Z. Okay, so you just need to simplify your answer further to get W, and this is what you get. It's not too difficult to obtain this, because just illustrate, if your W is equal to, okay, let me just go down further. Right, so this is the replacement we have been talking about after you do the rearrangement, so that one side is exactly minus 1 plus root 3I, and you ultimately you make a comparison. You notice your Z is replaced by 1 over W. That means that if your Z is replaced by 1 over W, so your W is 1 over Z, so end up with this. Okay, and you have found your value for Z, and one of the value of Z you have found out is one of the value. So how do you get the value for W? It's not too difficult, because it's 1 over, okay, minus 5 pi by 6I, and you can just bring everything to the numerator, where the sign will change, the power of the sign will change. So it will become, for the first root, after you take reciprocal, it will become 2 to the power of negative 1/4, then E multiplied by E to the power of 5 pi by 6I. And similarly, you can obtain the rest of the other 3 roots. Okay? Alright, so now we shall go on to question 2. Now, in this question 2 here, they said a graphing calculator is not to be used. So you can't use PC, I mean, and you have to show everything is possible, all the working, okay? Right. Necessary working, don't keep. Okay, first part, given P and Q, your job is to find Z. So P is given to be 1 plus I, and Q is given to be 1 minus 1 plus square root 3I. So how do you find your Z? Basically, just substitute your P and Q inside, and then you have to find the complex numbers in the form of x plus I, y, right, for Z. It's already, your P and Q is already in the form of x plus I, y. So in order to get your Z, what you could do is, you just need to convert this complex number, which looks so complicated because it's in fraction form, into the form of x plus iy. So the first thing is get rid of the I in the denominator by multiplying by the conjugate of q, okay, which is minus 1 minus square root 3I, both numerator and denominator. And just bear in mind again, just recall this is a very important result here. W multiplied by W conjugate is mod W squared. So in this case, when you have minus 1 plus root 3i multiplied by the conjugate, which is minus 1 minus root 3i, it should give you minus 1 square plus square root 3 square, which is actually 4. Okay, so the denominator would be 4, numerator, just normal expansion, okay, just multiply it out and simplify so that later you can regroup it. Real part together and imaginary part together. In other words, it means that the real part is this one, imaginary part is this one, okay? Right, the imaginary the I together. Okay, then you try to simplify. This is your answer, exact form. So this is the Cartesian form, x plus iy. Okay, then after that second part, let's look at it. What are you supposed to do for part 2? They say, considering the modular and argument of P and Q, find the exact value of mod Z and argument of Z. So basically, if you look at it, they already give you a clue that you have to find the modulus and arguments of P and Q. So which means that what you are interested now is not so much on x and y, but what you are interested now is more on this, where you get R and P term, modulus and argument. So by now you should know how to find the modulus and argument of complex number. Modulus is quite easy, square root of x squared plus y squared, right? Okay, but the argument here again, just recap again, this is very important, is locate the point to know exactly where it is so that you can find the argument correctly. For example, in this case, your P is 1 minus I. The coordinates is 1, negative 1, which is 1, negative 1. So it will be somewhere here where it is 1, negative 1. X positive, Y negative. It's in the fourth quadrant. So this will be your complex number and therefore this is your argument. Right? Now, what's the first thing you do? Remember, recall what we do is we find the basic angles. And the basic angles is obtained by using tangent inverse, right, y over x. Your y is minus 1, but we are talking about basic angles, which is a acute angle. So what we need to do is just take the ratio of the absolute values of x and y. So in this case, it's just tangent inverse 1 over 1, okay, y over x. But this is only the basic angle. It doesn't include the direction, which is clockwise direction. So as a result, you notice that first, you find the basic angles, and then you need to include the direction. The direction is clockwise direction in fourth quadrant, so it's just negative of the basic angle. Okay, and you try to simplify this. So just bear in mind, if you want to find the argument, this is the part a lot of people always make mistakes. You just remember, locate the point, and depending on which quadrant, if first quadrant, the basic angle is your argument. In second quadrant, the basic angle is this one. So the argument actually in the second quadrant is just pi minus the basic angle. Okay, the first quadrant, the argument is just a basic angle. And when it comes to the third quadrant, your point is in the third quadrant here. Okay, right? Then in this case, in order to find the principal argument, it will be this angle here. So this is your basic angle. Therefore, the angle in the third quadrant, the argument, will be pi minus the basic angle, but it's actually in clockwise direction. So therefore, you have to put a minus indicating it's clockwise direction. Right, and finally, fourth quadrant, which I've actually explained already. In this case, it's actually the same as P. This is the fourth quadrant. Just negative of the base. This is your basic angle. So the argument is just negative of the basic angle. Okay, so therefore use the same thing here. You will be able to work out the argument and modulus of Q respectively. Okay. So in this part here, this is what you get for modulus of Q and argument of Q, which lies, your Q lies in the second quadrant, x negative, y positive, second quadrant. Okay, so with this, then you can actually work out modulus of Z, which in this case is mod P over mod Q. Work out the mod P and mod Q, just do the substitution. And argument of Z is argument of P minus argument of Q. Now, if you work out your argument of P wrongly and argument of Q wrongly, your argument of Z definitely will be affected. So you have to be very, very careful when you try to work out the answer. Now, if you, after you work out the argument of Z, if your argument of Z falls outside the range from minus pi to pi, what do you do? In case where it is too small, okay, it is too negative, then you just need to add multiples of 2 pi. That means you add 2 pi, not enough, you add 4 pi, and so forth, okay? Now, if it is too big, right, that means it is too big, much bigger than, it's bigger than pi. Then what do? You make it smaller, right? So you just take away 2 pi. If it is not enough, then you take away another 2 pi, or you take away 4 pi, and so forth. Okay, until it falls in range from minus pi to pi. Okay, that's what you do, okay, if you want to find the principal argument. All right, look at the last part of the question. The last part of the question, they ask you to show. They ask you to show a result, okay? They ask you to show that sine of 11 pi by 12 is equals to, let's look at this, is equal to the square root 6 minus square root 2 over 4. Okay, this is what you need to show. Okay, now if you look at from what you have worked out from part 1 and part 2, from part 1, this is what you have gotten from part 1. Okay, now from part 2, actually, you have not really written down the form of the complex numbers, but you have worked out the modulus and argument of the complex numbers. In other words, you have the modulus and argument of the complex numbers, modulus and argument of the complex numbers. Basically, you will be able to write down the complex number in the trigo form, which is r cos theta plus I sin theta, where your r is root 2 over 2, your theta is minus 11 pi by 12. So this is what you get. Trigo form. Okay, now this is from part 2, okay, and in trigo form. And this is from part 1, which is in Cartesian form. So these two complex numbers actually are the same complex numbers, but in different forms. So they should be equal, right? It's just that the form is not the same. Now, and your job is to show sine theta. So you ask yourself, if you want to show sine theta, now this complex number itself consists of real part and imaginary part. If you want to talk about sine theta, the one involving sine theta is actually the part that is actually the imaginary part. So what you need to do is you just compare with the imaginary part. Okay, let's continue. So this is your imaginary part, and you compare the imaginary part on the both sides of the complex numbers. Okay, so therefore, comparing imaginary part, you will end up with, don't forget where does the root 2 over 2 come from? From here, where you have to actually multiply in, okay? Right, so you compare both sides, imaginary part of both sides, you will get this expression, and if you look very carefully, you notice that they are quite alike, but not exactly the same yet. Because this part here, there is no negative sign, okay? If you look at it again very carefully, there's no negative sign. So what should you do? Never mind, you have written down the expressions. Then you just think of first, you probably have to get rid of the negative sign. Secondly, you probably have to get rid of the root 2 over 2. How do you get rid of the negative sign? You need to use some property of trigo, which is very important. Sine minus theta is minus sine theta. In other words, you can take out the minus sign. So in this particular case, there's a minus sign here, where if you use this properties, you notice that it's just sine minus theta is minus sine theta, and that's how you move the minus sign out of sign. And once you move the minus sign out of sign, the expressions itself will become something like that. Minus square root 2 over 2 sine 11 pi by 12 is equal to 1 quarter 1 minus square root of 3. Okay, so now you have get rid of the minus sign in the trigo expression of sign. What is the next thing you should have do? The next thing you should do is get rid of the minus root 2 over 2. You bring it over to this side. And once you do that, hopefully you will be able to end up with this answer. Okay? You will end up with this answer. Okay, so this is what you will get. Of course, after you get the answer, don't be too happy because you won't get the exact form yet. Because you will end up, when you bring the root 2 over, it will appear in the denominator. So what you could do is you actually have to rationalize it. That is, this part here, there's root 2, after you bring it over in the denominator, so you have to rationalize it. You just have to multiply by root 2 over root 2. Okay, so from here, this part, you just multiply by root 2 and simplify further to get the required form. Okay, that's not the end. That is actually the end of the question. But then actually there is another alternative method which I could actually elaborate a little bit further. So what you could do actually is you draw the diagram. Okay, you're using the Argand diagram. Okay, let's continue. What we get from here is we use Argand diagram. Now, just look at what you have found from part 1 and part 2 for your complex numbers. Huh? Okay, first of all, if you look at the trigo form, you notice that the angle is minus 11 pi by 12. It's this angle. Minus 11 pi by 12. Okay, and you know it corresponds to the point that this is the y coordinate, right? X plus I, y. So this is the y coordinate. So the y coordinate is actually here for that point. In the third quadrant, this is the point, okay? In the third quadrant, this is the y coordinate, right? Now, you're not so interested in the x coordinate here because actually, if you want to talk about y, you just need what you find theta. You just need the opposite angle, the opposite side, and the hypotenuse side. And you know that actually this gives you the modulus, root 2 over 2. That means from here to here, this is root 2 over 2. Okay, so now, if you look at it, if I can find this angle, or actually if you look, you need to find this angle actually. If you look at it, you want to find sine of 11 pi by 12 in the second quadrant. Is actually sine is opposite over hypotenuse, where opposite is just this. Hypotenuse is actually this side, root 2 over 2. So basically it's just your y, which is this one, this is your y, right? Okay. Your y, this is it. This is what you have here, your y, divide by modulus, which is root 2 over 2. Because this one is just 1 quarter 1 minus root 3, okay? So y over this length. Alternatively, instead of actually working out your sine of minus 11 pi by 12, so in other words, this is what I have. But if you work out this one, you have to be very careful because you still have to remove the negative sign inside. So it may not be so ideal, right? Because you need to work out extra steps, which is in this case is y is 1 quarter 1 minus root 3 divide by hypotenuse, which is root 2 over 2. Okay, then of course you have to try to get rid of the minus sign and just go on and on. Okay, a few more steps. So this is one way of doing it, right? Now, alternatively, if we look at it again very carefully, you notice that if this angle is 11 pi by 12, that means that actually by symmetry, this angle here will be, this is minus 11 pi by 12, then the other angle in anti-clockwise direction will be 11 pi by 12, which falls in the second quadrant. Okay. Now, and if this is your y, then on this side, this actually is negative of that, negative of this y coordinate, right? So this is your y coordinate in the in the second or first quadrant. Okay, so now if you want to find 11 pi by 12, this angle, opposite hypotenuse, opposite is just y here, which is negative of 1 quarter, 1 minus square root of 3. Hypotenuse is this one, which is square root 2 over 2, which is actually the modulus of the complex numbers. So if you look at it now, well, it makes sense, right? You get this answer. So it's either way, okay? It's either you try to work out your sign, minus 11 pi by 12, and after that you get rid of the negative sign by drawing the Argand diagram, or you just straight away from minus 11 pi by 12, you work out 11 pi by 12, the sign of them directly. Okay? Alright, so that's other alternatives. Of course, there are other ways of doing it, but basically it's just with the Argand diagram. Okay? Right, so let's go on to the last question. Now, in the last question here, we are supposed to find W and Z given a set of simultaneous equations. This one, I don't think you need me to elaborate. It's quite standard. Solving simultaneous equations, like what you learned last time in secondary school, you just use either elimination method or substitution method, whichever you find is more convenient, okay, or it's easier for you to do. So for the first part of it, actually, right, looking at it, in fact, you could just hold on. Okay, in this particular case, probably you could try to consider using substitution method, where if you look at it, W from equation 1, let's call equation 1 and 2, the two equations, equation 1 and 2 respectively. So from equation 1, you can just cross multiply, bring your Z over, and you will be able to get by cross multiply, bring the Z over, here, you will be able to get W equals 3 over 2 IZ by bringing this over, okay? So after you get to this expression, what you do next? Substitute inside here, okay? So when you do the substitution, your W will disappear, right? And your Z will appear. So this is the substitution into equation 2. Okay, now you look at the equation again. How many unknowns do you have? Well, you still have two unknown because you have Z conjugate, right? But it's better. It's better than Z and W because Z and Z conjugate, at least they're related. It's like relatives, so it's easier to work with, right? With the relative. But when you have an equation involving Z and Z conjugate, it's advisable for you to actually just let Z to be x plus iy. Because once you let Z to be x plus iy, you will be able to work out your Z conjugate because it will be x minus iy. Okay, so this is the first thing you should try to do if you have Z and Z conjugate in the same equation. By letting Z to be x plus iy, then you will be able to work out the conjugate of x plus iy, which is x minus iy. Okay, then one equation, two unknown, right? X and y. If you can find x and y, then you can find your Z because basically your Z is just x plus iy. Okay, so what you need to do? One equation, two unknown. Compare the real part and imaginary part. Okay, so in this particular case, you may try to simplify further before you do a comparison. For example, you just need to simplify this equation into this form. Minus 3i x, then you multiply the minus 3i inside, it becomes plus 3y, right, equal to 4 plus 4i. Then you make a comparison, 4, and the real part is x plus 3y. So one equation x plus 3y equals to 4. And the second equation can be formed by equating the imaginary part. The imaginary part is 4, okay? Then in this particular case, it's just minus y and minus 3x. So it's minus y minus 3x is we're talking about, okay? Right? So the imaginary part is minus y minus 3x. It will be equal to 4. So second equation. Okay. Two equations, two unknown. You solve for your x first. Solve x and y simultaneously. You can use your GC. Once you know your x and y, you can write down your z because your z is x, which is minus 2 plus yi. Your y is 2, so it's minus 2 plus 2i. And from here, you can work out your w because what is your w? Your w is equal to, if you can still remember the previous substitution, the w is equal to 3 over 2iz. So once you know your z, you just need to substitute your z inside, which is minus 2 plus 2i. Simplify further, and you will be able to find your w. Okay, so that is the value for w. When we are basically done for the first part, let's look at the last part. Okay, now the last part is a bit more challenging, and the last part is similar to what you have done before in the block part I'm talking about. Where now you have three complex numbers, you add in one more w, where your w and z you have found out already. Okay, in the previous part you solved simultaneous equation, you found out your w and z, right? So now you just need to add in one more point. But what else did they tell you? They say this w, z and v forms an equilateral triangle on the Argand diagram. Right? Forms an equilateral triangle on the Argand diagram, and this is WVZ. And you are supposed to find v. When they say ask to show v can be expressed in this form, in other words, what they're asking you is to find v. How are you going to find v when you know your WVZ is actually an equilateral triangle? Okay, let's try to draw the diagram. It helps you to visualize what is going on. Okay, now when you try to draw the Argand diagram, it looks something like that. Just look at this part. It will look something like that. So this is what you see on the Argand diagram. Okay. Now, so in this Argand diagram here, this is your point Z, which corresponds to minus 2, 2, the coordinate, and W, which corresponds to minus 3, minus 3. Okay. So this is what you have previously. You have found out, then you can write down the coordinates. You can locate the points in the correct quadrant. Now, so what else do you know? You know that WZV forms the equilateral triangle, and you know the argument of V is negative. So given argument of V is negative, that means V is either in the third quadrant or the fourth quadrant. Okay, so in this particular case, you really work it out, that it will be the fourth quadrant. Now, looking at this diagram, now if this is an equilateral triangle, it simply means that these three sides are all equal. These three sides are all equal, and not only that, okay, not only that, each of this angle will be the 60 degrees, which is 3 pi by 3 radians. Okay, now your job is to find V, but you have your W and you have your Z. So how are you going to find V using Z and W? Looking at the relation. Now, look carefully, you'll notice that actually, if you try to rotate your WV by pi by 3 radians, okay, in anti-clockwise direction about the point W, you will be able to obtain WZ, right? Simply by a rotation. WV rotate pi by 3 radian anti-clockwise about W, you will get WZ. Now, if this is the case, then you just need to make use of ZW to find your V. So you need to establish a relation. When you a complex number representing WV basically is just V minus W. A complex number representing WZ is just Z minus W. Okay? So what you need to do is basically you just need to rotate V WV anti-clockwise by pi by 3 radians. So you just multiply by EI theta, where theta in this case is pi by 3. Okay. And you will be able to get your W, which is Z minus W. Right? Okay. So from here, you notice that your job is to find V. Find V. So you have to rearrange everything. First, bring the pi by 3 over to the other side so that you can make V the subject. Then after that, bring the minus W over to the other side. Okay. Right. Now, if you really need to evaluate V, then you have to substitute your complex number W and Z inside, where W is minus 3i, and your Z is minus 2 plus 2i. But in this particular case, if you read the questions very carefully, that's not required by them. Okay, so let's look at this solution here. This is what I've explained to you earlier. Rotating ZV minus WV anti-clockwise. So you just multiply by this. Multiply anti-clockwise. By angle theta, in this case the theta is pi by 3, you will get your ZW. Okay, so you just need to rearrange it and make your V the subject. Okay, once you make V the subject, then you notice that, yeah, you will get this form. Then you need to see what is the answer they want. Okay, the question is asking to show this V must be written in this form. So if you want to get this answer, then hopefully what you could do is you will have to try to rearrange such that you get this. Right? Not only making V the subject, you have to group all such your W is together, then your Z. Okay, so you just need to rearrange it. Okay, that your W, group it together, the W and W, group it together. When you try to simplify your expressions, and then from here you simplify further until you get to the required form. Then you can identify, okay, if this is the required form, what is your A? This will be your A. Right? Okay? Okay. So that's it. That's where you need to stop. But of course, if you are supposed to find your V, then you have to proceed further by substituting the W and Z inside the equation and simplify your answer further. Okay? So, but for this case here, this is where you need to stop according to the question. Okay, finally we come to the last part, argument of W minus V. Okay, what do you do? Find argument of W minus V. Okay, so now okay, let me just erase off this part because what you need to do is you ask yourself, when you talk about argument of W minus V, what is the closest? The closest is you try to recall when you're actually talking about the half line, right? Argument of Z minus A equals to theta. Okay, let's say this complex number A is represented by a point A on the Argand diagram. What does this represent? Okay, let's draw out the Argand diagram, then you will be able to see. Right. Now, let's say your complex number, the point representing A is point A. Yeah, right? Then Z minus A is actually represented by a line segment where that is just any point on the line segment, half line. Okay, and the angle theta, if this theta is fixed, that means that actually it must be a line, because when this is fixed, that means that the angle where the line segment make with the positive real axis is constant if it is fixed. Okay, so you notice that when you talk about this locus is actually a half line. The reference point for argument of the Z minus A, the reference point is point A. Now you just refer back to this question again. What is this question about? This question is talking about argument of W minus V. Now, if it is W minus V, you look at it, instead of comparing it with Z minus A, what is your reference point? Your reference point will be the point V, okay, representing the complex number V. So the point of reference. So in other words, it's a line segment joining W and V. So this is your W, this is your V, right? But the reference point is at V, which means at the point V, at the point B, you draw a horizontal line so that you can find the argument at the point B. Okay, the reference point is here. So that means that actually reference point is at V. So here you draw a horizontal line, a positive red axis, parallel positive red axis, and this is the required argument. This will be argument of W minus V. Okay, right. How are you going to find this argument? What is this angle here? Well, if you look at it again very carefully here, notice what we have observed just now, the coordinates of Z, coordinates of W, right? And the angle, this angle, all this angle in all the angles of triangles, interior angles of triangles, they're all pi by 3. How are we going to find this argument? Well, if you look at it, to find this argument, what if I have this angle? If I have this angle here, then actually this argument here is just simply pi minus theta, but this is positive angle, right? But this is which shouldn't be the way because it is in clockwise direction, so it should be negative to indicate the direction, clockwise direction. So it's negative of bracket pi minus theta, right? So if I could find my theta, I will be able to find the argument of W minus V. So what is my theta? Now, if this is the angle theta, then this angle will also be theta if these two lines are parallel. So, would I be able to find this angle theta? Right? If I can find this angle theta, then everything will be solved because then our argument of W minus V is just minus pi plus theta. Okay? So, if I can find my theta, things will be solved. So, how do you find your theta? What you need to do basically is look at the triangles you have. This is a triangle, okay? Construct a right angle triangle first. Because you have the point W, you have the point Z. So if you look at this triangle here, you will be able to calculate this angle. Right? Okay, let's say I call this point P. You will be able to calculate the angle of ZWP. If this is a right angle triangle, the angle of ZWP is just tangent inverse. If you have the opposite side and you have the adjacent side. The opposite side is from here to here. Now, this one is actually 2. This value here is minus 3. So, from here to here, the height itself is actually 2 plus 3, which is 5. Right? Opposite side is 5, which is ZP. ZP is 5. Now, what next? Then you have to ask yourself, how about this length here? Now, from here, this angle, this y-x coordinate is minus 2. And this one, the x coordinate is actually minus 3. So this distance from here to here, actually, this distance is 1. So this distance will be 1, which is your WP. So actually your adjacent is 1. Opposite over adjacent. So you can actually work out this angle ZWP. Okay. Now after you work out the angle ZWP, what's next? This is not the required angle, right? The required angle is theta. So if you ask yourself, what is your theta? Your theta is actually angle ZWP, where this is my point P, okay, minus of the angle of pi by 3, isn't it? If I take this angle here, right, and minus of pi by 3, I will get my theta. Okay, so my ZWP is actually tangent inverse 5. So it's both, that means my theta is just tangent inverse 5 minus pi by 3. So once I have my theta, I just need to substitute inside here. I will get my argument of W minus V. Okay? And just leave your answer in form because what they want is the exact value. Right? So there's no need for you to evaluate the angle further. Okay? So that will be the end for questions 1 to 3 that I want to discuss today.